So we're now moving on to video 4C of this unit. So we're going to learn one more method to solve a system of equations, and this is the last method that we will learn. So we've already talked about graphing, and we've already talked about substitution, and now we're going to learn elimination. So by the end of this video, you're going to know how to solve a system of equations through elimination. So now we've learned three methods. Once we're done going through these, when you get questions, you're going to be able to choose which method you want to use. So if you find substitution to be the easiest, then go ahead and use that every time. If you find elimination to be the easiest, once again, go ahead and use that every time. It is completely up to you of how you're going to solve this. The one method I will be weary of you choosing is going to be graphing, simply because if you get an answer, say 2/3 is an answer, it might be hard for you on a graph to look and say, okay, that's going to give me 2/3 because you're going to be approximating it at that time. And if your graph is drawn slightly off, then you might be approximating the wrong answer. So graphs sometimes aren't that good of a method to use, but it's good to teach you graphs first because we can visually see what systems of equations are and what our solutions represent. That it's where the two graphs overlap, it's the solution that they both share. But it might not be the best one if you're going to choose which ones you want to do. All right, so let's go ahead and go through a couple of examples and learn how to solve using elimination. All right, so before we actually go into any problems, I want you to write these steps down because this is what you're going to need to refer back to when you're doing solving a system of equations through elimination. All right, so our goal through elimination is exactly what it sounds like. We're trying to eliminate one of the variables that's given to us in our original problems. So the first thing that we're going to do is we need to rewrite our equations so that our variables and constants are lined up above each other. And the best way of doing this is standard form, but it doesn't have to be. And what I mean by lined up above each other is if I have 2x minus y is equal to 10, well, my equation underneath, I need to make sure that my x's are lined up, so they're written above each other, that my y's are written above each other as well, above and below, and that my constants are written above and below each other as well. So we're lining up and putting them exactly where they are so that they're directly above each other. Right? Sometimes this is in standard form right here. Standard form is the best, but it doesn't always need to be in standard form as long as if they're just lined up. Right? Then our second step that we're going to do is you will then choose a variable that you want to eliminate. So you're going to choose x or y. All right. Now you will choose which one. Now, once we go through this and we do this a few times, it should jump out at you which one you should eliminate for each problem, but it doesn't matter. Right? You can choose x and your friend can choose y and you'll still get the same answers, just going through a different route. Right? Then the next thing that you're going to do is you will manipulate your equations so that one of your variables coefficients, so that's the number in front of our variable, are opposites. All right. And we will do this through multiplication. And in case you don't remember, what are opposites? Well, the opposite of 10 is negative 10. The opposite of negative 5 is positive 5. The opposite of 1/2 is a negative 1/2. So remember, opposite numbers are on the opposite side of 0 on our number line, but the same distance from 0. So it's just a positive and a negative of that number. So a negative 10's opposite is positive 10, and so on. All right, so it's the same number, just different signs. And then after we manipulate through multiplication, and we're going to go through this, after we manipulate our equations so that we have opposite coefficients of one variable, we will add the two equations together. And by adding them together, if our variable has opposite coefficients, well, negative 10 plus 10 is going to equal to 0. Negative 5 plus 5 is going to be equal to 0. 1/2 plus negative 1/2 is going to be equal to 0. So when we add them down, it will eliminate one of our variables. All right, I'm not going to talk about 5 or 6 because we're going to talk about them when we actually go through. I think it'll be easier to explain that as we're solving. But these are the hardest steps of elimination and what you really need to make sure you get down. And once you get those down, it's just the same thing over and over again. And it actually becomes quite easy. All right, and then once you finish the step 4, this is exactly what you did in substitution. So it's really not anything new anyway. All right, so let's go ahead and go through a couple examples in this video. All right, so I put the steps to solving system equation elimination here so that way we can check off each one as we go through it. And we're going to start with an easier one and work our way up to ones that might be a little bit harder. All right, so our first step is to rewrite these systems of equations so that our variables and our constants are all lined up above each other, and they already are, so there's nothing we need to do with that. So I'm just going to go ahead and just rewrite them here, just so that way I have that part going. All right, so now from here, our next thing is we want to choose which variable we want to eliminate. Now, let's be strategic about this because we said that we eventually want to have our variables coefficients to be opposites of each other. So either if I see a variable is already a plus and minus, then that might be a little bit easier for me to choose that one. Or if I see that they already have the opposite numbers, then I'm choosing that one to begin with. And here for y, this y's coefficient is -1 and this y's coefficient is +1. And -1 and +1 are opposites of each other. So I'm already going to just choose y because it's set up for me to not have to do anything else. All right, so I rewrote, I didn't have to, they're already in standard form. I chose which variable I want to eliminate, and I do think you should get in the habit of drawing the arrow on which one you're going to eliminate because it can help remember which one you're trying to multiply to get to an opposite number. All right, then we didn't need to do anything with this one because they're already opposites of a -1 and +1. And then we need to add down. So what we do is we just add these two equations together. So we would do 3x plus 3x, which gives me 6x. -1y plus 1y gives me 0y. So they eliminate, they cancel each other out, hence the method elimination. And 4 plus 2 is then going to give me 6. All right, so now by adding these and having the opposite numbers, I eliminated my variable y. Because remember, if we have an equation, we can only solve that equation if we only have one, if there's one unknown. Both of these have multiple unknowns, so we can't solve them as is, so we need to manipulate. By adding them together and eliminating our y, we now have that 6x is equal to 6. And I know I can solve this just based on a regular equation that we've solved before, so x is then equal to 1. All right, now that we know what x is equal to, that x is equal to 1, I can go ahead now and solve for y by simply plugging in 1 into any of my variable x's into the other equations. All right, so that's what we mean by here, by solving for a remaining variable to step 4, and then substituting it back into the other equations to solve for the other variable. So I'm just going to go ahead and pick this one because y is a positive y. It doesn't matter which one you choose, but if I were to pick and substitute my x into my top equation, I'd have one more thing I need to do because my y is a negative, so I'd have to remember to divide by that negative, and it might just make me forget, or this might cause a few more steps. So I'm strategically picking this one because I know it's going to be less work. So now we have 3x plus y is equal to 2. Well, instead of 3x, I know x is equal to 1, so I can substitute that in there. So now I have 3 plus y is equal to 2. And my last thing is going to be to isolate that y, so y is then equal to -1. So we will always write our answer in our ordered pair, so 1, comma, -1. And that is the ordered pair or the solution that will satisfy both of these equations at the same time. All right, so now we're going to go through another example, and this one's not going to be flat out given to us of our opposite numbers, so there's going to be a little bit more that we need to do to solve. All right, so let's now go through our next example. So same steps every time. First, we need to rewrite them so that our variables are above and below each other. This is already done for us, so I'm just going to rewrite them just so this way I can start to manipulate them and write on them if I need to. And it's just a lot clearer when you're writing them separately, all right, than just from the original problem. Okay, so now the next thing is to choose which variable we want to eliminate. And remember, we're going to be strategic. None of my variables here are opposite signs. However, I see that my y is a +4 for both of them. So since they're the same number, it's going to be really easy for me to manipulate my y's to get them to be opposite numbers. So I'm choosing y to eliminate. But remember, you can choose any variable you want. Now we want to manipulate our equation so that our coefficients of that y are opposite numbers. In both of these cases, our coefficient is a +4. So what can I multiply to one of these equations to make that +4 to be an opposite or -4? And that's -1. And it doesn't matter which equation you choose. I'm choosing this top one just because I feel like it. And what I need to do is I need to multiply every single number by that -1. So -1 times 3x is now going to give me -3x. -1 times +4 is 4y is now going to give me -4y. And -1 times -6 is now going to give me a +6. All right, so then once I multiply that, I don't need to do anything to the other one because it's already a +4y. So I'm just going to go ahead and write that underneath. All right, so now by manipulating or multiplying that first equation by -1, I have my opposites in front of that variable y. Once we do that, we can then go ahead and add down. So -3x plus 7x gives me 4x. The y's are now going to eliminate, and 6 minus 14 is going to give me -8. Once I do that, I now have a very easy equation for me to solve, and I can do that by just dividing by 4. So x is going to be equal to -2. So now that I solved for x, I now need to pick which equation am I going to substitute this back into to solve for. And it really doesn't matter. Since both my y's, because I'm substituting this in for x, since both my y's have a coefficient of 4 in front of them, then it won't matter what I'm going to substitute in necessarily for that because I'm dividing by 4. So I'm going to pick this top equation simply because 3 is smaller than 7. So it's a smaller number I'm multiplying by with -2. So I have the equation 3x plus 4y is equal to -6. I know now that x is equal to -2, so where I see x, I can substitute -2. So now I have 3 times -2 plus 4y is equal to -6. And now I just need to go ahead and solve for this y. -6 plus 4y is equal to -6. Well, now when I add over this -6, I now get 4y is equal to 0. And when I divide 0 by any number, it's also going to be 0. So that means that my final answer is going to be -2, 0. And that's how we need to write it, as an ordered pair, and it satisfies both of these equations at the same time. All right, so now let's go ahead and one more question that we're going to solve, and that's it for this video. All right, so here's the last example that we're going to go through. So our first thing was always to rewrite them so that our variables and constants are lined up. And you see here they're not. Here we have our x's and y's on one side of the equation, and here we have our x and y's on separate sides. So I'm going to actually take this first one, 5y is equal to 6x plus 25, and I'm just going to rewrite this so that way my variables can be lined up. And I'm going to now move my x to the same side as my y, since my other equation had the x and y's together. So now I have -6x plus 5y is equal to 25. Right? And then I still have the equation of -2x minus 4y is equal to 14. So for this one, I needed to actually rewrite them. All right, so now I'm going to choose which variable I want to eliminate. When I look at this, I do see that my y's are opposite signs, so maybe I want to jump and eliminate the y right away. However, I know that 4 and 5, if I'm going to try and multiply them to get them to opposite numbers, it's not just going to be where I need to multiply one equation. I'm going to have to multiply both 5 and 4, since 4 can't go into 5 an even number of times, or a whole number of times. So what I'm going to do now is I'm actually going to eliminate my x. And the reason why is, even though they're both negatives, I know that I can multiply 2 very easily to get to that 6. So I see that it's going to only require me to multiply one equation as opposed to multiplying both. So if I want my x's to be opposite numbers, this is a -6. Well, that means that the opposite of -6 is +6. So I'm asking myself, then -2 times what will give me a +6? Well, I need to multiply this by -3. Right? By multiplying it by -3 times -2 will give me a +6, which will give me opposite coefficients. So I'm going to rewrite -6x plus 5y is equal to 25, because I'm not doing anything to that top one. And now I'm going to distribute this -3 in. -3 times -2 is +6x. -3 times -4y is going to give me +12y. And -3 times 14 is going to give me a -42. All right, so now once I have the opposite coefficients in front of a variable, which I do here, I now just need to add down. All right, so when I add down, the x's are now going to eliminate, and now 5y plus 12y is 17y, and 25 plus -42 is -17. Once I get down to my one variable, I just solve like I normally would, and y is then going to be equal to -1. And once I figured out what y is equal to, I can now go ahead and substitute into any of these equations to solve for x. It really doesn't matter which one you're going to choose. I'm just going to go ahead and choose this one here, since my x and y's are already on opposite sides of the equations, but it really doesn't matter. So now 5y is equal to 6x plus 25. So instead of y, I know it's equal to -1. So 5 times -1 is equal to 6x plus 25. Well, 5 times -1 is -5, so 6x plus 25. And now I need to isolate that x all by itself, so I'm going to go ahead and subtract the 25 to move it to the other side. So -30 is equal to 6x. And then our last step is going to be divide by 6, so that means x is equal to -5. So our ordered pair, or our answer, is x is -5 and y is -1. So this ordered pair will satisfy both of these equations at the same time. And if we were to graph them, that's where the graphs would overlap, and that's where the graphs would share. All right, that is it for this video.